Okay, we are now going to discuss something that is related to functions, but we will talk about a special kind of function, and that is the magical thing that is called numbers. So we spoke that functions can really be with houses, with people, with objects. Here we have a special class of functions, and that is the number line. Number line is very instinctive and intuitive, and don't let people tell you that was invented recently by mathematicians. I think it's one of the most intuitive things that everybody, even a kid, can understand, that there is, besides numbers like counting numbers 1, 2, 3, 4, 5 and so on, they all know, they have a feeling that there's something between 1 and 2. Just draw a line on the paper, show this is 1, this is 2, this is 3. So they understand, hey, what is going on between 1 and 2? They can be, we invent things called fractions, decimals, whatever. They understand there's a lot of points between 1 and 2. Even better, forget about a number line. There's a child, he says, I'm 2 years old. Other guy says, I'm also 2 years. He understands it can be million children 2 years old, and still one is older than the other one. So this is so natural that it's just, the whole nature is full of things that are related to the concept of number line, meaning the sense that besides counting numbers, 2 apples, 3 apples, 4 apples, there's something that we say they can be stuff that is 2.5 apples or 2.5 years. Now, what is special about numbers? The specialty about numbers is that it is unbelievable dense, in the meaning that you can have a list of a million people, and every person has a different house, or a billion people, a trillion people, and you waste a lot of paper and a lot of time to write down every person and his house, or every person and his age, or every person and his social security number. All these are legitimate functions. Here we have something that we can write down information about a certain box, as we said last time, box A, how it relates to box B, in a very compact form, and that is through rules that are called operators. I'll explain what I say. We can imagine that we have a box that has numbers from, let's say, only from 1 to 2, or from 0 to 1, and there is unbelievable a lot of numbers there. So how in the world can I list? How in the world can I make a list and tell you for 1.001 his friend in box B is 7.5. For 1.002 the friend is 13.76. Can I start enumerating every single decimal or every single fraction between 1 and 2? I'm not even interested to do it just between 1 and 2. I'll keep on writing and writing, I'll never end. Let's say I have for every single point between 1 and 2, I want to make up a certain, I want to create a certain output and something that should be in box B that's going to match with the one in box A. It's a very, very tough thing to do. It's impossible to do, actually, because there's always going to be certain points that you're going to leave out. However, it is possible to do. Magic. If I use certain operators, then I just use this machine and I tell every single number between 1 and 2, just put that in that machine, that function machine, and you will get the result. So it is like I'm saying a rule. Let's call it like a rule. So I don't need to enumerate every single. It's not like I need to tell you about every person where he lives. No, I can do it in one quick line. I can give you trillions upon trillions of information. What an interesting thing. How do I do it? I tell you every number between 1 and 2. You want to know what is his offshoot, his offspring? The answer is multiply that number by 3. That's a nice machine. It's called the machine that has a big sticker on it. It says times x times 3.5. That's how we call that machine. It's made in China, a special machine that whatever you put in there, it multiplies by 3.5. The machine knows by itself. So you have no problem. It can handle infinite numbers between 1 and 2. It knows exactly what to do. So this concept that you have rules what to do is very, very good, because a rule tells me you don't need to enumerate, just follow the rule. You want to know what to do with the number 1.76354. Very simple. Multiply by times 3.5. You have a pocket calculator, you can do it yourself. You'll find out what is the offspring of this thing. What is the number that results in box B when you put in this number in the function machine. So we have here box A. You put him in a special machine. We give this machine special attention because he's a very good machine. He can handle infinite amount of numbers. The machine is called multiplication by 3.5. That's the trademark of this machine. Now you can do a lot of different machines. You can buy it. You go into that store to buy these machines. A lot of different machines are available. You can make times 7.9. You can make times -5. You name it. You can make a lot of things. However, you can also make what we call squared. That you take a number between 1 and 2. Let's say the number would be 1.3. You square that number. That means 1.3 times 1.3. 1.69. Why not? You can cube it. You can make 1.3 times 1.3 times 1.3. Beautiful. You go to the next shelf of the store, you buy a different function machine. It's called machine of sine and cosine. So if somebody learned some trigonometry, they know that every number can have a sine and a cosine. A sine, you can go sine of 45, let's say you go with degrees, sine of 45 is 0.7071, sine of 30 is 0.5. You can just use your calculator. So we understand that every single number, and right now I'm just limiting myself from 1 to 2. I don't need to do that. I can say, you know what? We can be more liberal than that. We can allow every number from 0 till 100, or every number from 0 till billion. Just follow the rule. You take the sign of that, or the power. As I said, there are many, many, many things that you could do with this interesting number machines that have special operators. So again, I want to sum up what is special about this class of functions. Number one, it can only deal with numbers, meaning to say it is not dealing with houses or people, it's dealing with numbers. And numbers here is meant any interval from 0 to 1, from 1 to 2. It's dealing with numbers that are continuous. That's how it's called mathematically. But we understand. I don't like to use fancy words. We understand very well what it means. And then we have these special operators, I like to call them, that are very, very magical in the sense that you don't need to make a special list of all the numbers that you want to use and all the outputs. No. You just make one symbol that's called multiplying, or one symbol that's called dividing by something, and that's going to be the rule that's going to follow through all the way. So this is the specialty about this kind of function. The interesting part is that, however, that a function that belongs to this class we can again subdivide in two categories. One of them is that the output is very similar to the input. Just like the input is a number that is on the number line, and with that I mean the idea that it handles infinite points or super infinite points. That is on one hand, and the output, this is an important thing to understand, I'll talk about it in the next video. The output also involves infinite points. Very important. I'll give you an example and then we'll stop the video. Let's assume we say like this: hey, the input, box A, has in his box all the numbers on the number line from 0 to 5. That is crazy amount of numbers. Infinite is not even a word for it. And we give you a rule. The rule is going to be as follows: you take every single point and you multiply it by 7.5, and then the result, you take the first 5 digits of the result. I just made it up now. It should sound a little bit weird. Why not? You could say the first 2 digits, you could say just the first digit. I just said why not. That's going to be the rule, what you're supposed to do. But listen here, what's going to end up happening is that the result, the box B, will not have filled in, even in any area whatsoever, all the blank points. There'll be a lot of holes there. I can prove it to you next video that a lot of numbers would be missing. So let's say you want to draw a line that's going to and that line was supposed to represent all the results that box A spit out. That line is going to have a lot of holes in it. It won't be a continuous line. So this, it is a good function, nothing wrong with it, but it's something weird about it. And next video we'll see what is weird about it and why with the first kind we can play around more, we can do much more tricks or handle easier if we make this function in a way that the first box and the second box both have this quality of a number line, meaning to say there's no empty points that are just not there, holes, at least in a certain interval. You can skip, it doesn't have to, it can be certain areas that they just don't exist. We'll give that in the next video. But at least if you take some interval, you should at least behave well in a certain interval that it's so dense he does not skip anything in that part. That will be discussed more in detail in the next video. Thank you for listening.